Hello everyone, we are from group IF-4PD-01. We would like to report our project in this semester. But before we report our project in this semester, I want to introduce you our project called SaveBite. In this SaveBite, we have two members with one project manager. This project is managed by our project manager, Miss Mir'atul Khusna Mufida, and our project leader is my teammate Bastian and Henriko Limbong, and myself as a member, Hamid. Before we start to report our project, I want to introduce why we built this project. So this project is built because in Indonesia there is much food waste, and based on this diagram, the waste composition for food is touch 40%, and because of that, we built this project to rescue the food surplus. And then the solution of our project is called with 4C. The first C is connect. This project will serve as a platform to connect merchant and customer. So the customer will buy the food surplus from the merchant. And then the second is control. The control means for the merchant. So the merchant in this project, this project will give prediction for the surplus food. So the merchant can control the production with the prediction. And then the third C is cost saving. And this cost saving means the food surplus price will be more cheaper rather than the normal price. And then the last C is contribute. This project will contribute to SDG 12 about the food consumption, and this project will contribute a lot because we rescue the food surplus. Okay, next our report for our AI evaluation. In this project we use two-stage method. The first we use PROPET algorithm, and then we use XGBoost algorithm. In the PROPET, it will process the time series data, and then our XGBoost will process the output from PROPET with external data that affect the output of PROPET, like the surplus food, like holiday or range intensity. And then based on the diagram in the PROPET, the result for the MAE is still high. It touched 13, and then the RMSE touched 17, with MAPE percentage touched 40%. It means based on the diagram, the PROPET prediction is outside the predict. And then in the second algorithm, the XGBoost, it shows the prediction is more accurate because it's already tested in the process. It's already proceed with range intensity or holiday data. In the diagram and the table, it shows the XGBoost. It shows the MAE touching 4, and then RMSE touch 4 too. In the diagram, the prediction is more accurate rather than the first prediction. And then for the overall, the hybrid two-stage stacking algorithm, Facebook PROPET, and algorithm XGBoost, the final MAE is 3.24, and then for RMSE 3.89, and then for MAPE, but in this case we use weighted one, so it's VAPE, it touched the 10%. And then for the performance testing, I will give to my teammate.
Okay, thank you, Hamid, for your explanation. For the next slide, I will give the explanation. Okay, this is the application testing and evaluation result. The load testing results show that the application successfully handled up to 50 concurrent users without any request failures, indicating good system stability and reliability. As the number of users increased, the throughput also increased, reaching approximately 5.4 requests per second. However, the response time grew significantly under higher loads, with the 50 percentile reaching around 2.9 seconds and the 95 percentile reaching approximately 3.8 seconds. These results indicate that while the system remains functional and stable under the test load, performance optimization may be required to reduce response times and improve scalability as the number of concurrent users continues to grow. Okay, we jump to the project achievement. For this semester, we successfully implement the core business of the main flow of our application, including users authentication, surplus food listing management, and in-app payment integration. And for the DSS or Decision Support System, we successfully develop and integrate our website or our final result with an AI-powered prediction that will generate the demand forecast to provide merchants so they could control their production per day. As our solution Hamid tell before. Okay, let's jump into the project deliverable. Okay, about 6% of the total functional requirement we not acquire the functional. We not implement it successfully. There is in-app payment because if we want to implement the in-app payment, we need to verify our mid-trans account so it could run in production. If we still in sandbox, we cannot use it properly, and it needs manual payment. We need to copy the URL, scan URL QR code, or we need to copy the VA and put it in sandbox input. And for the admin module, there is order cancellation handling. It is not implemented because we think it is not fair if admin have functional to cancel the order from the customer. It is not fair for the customer. We think it is good if customer have a full control for the order flow. Okay, for this from the system automation, there is Firebase FCM notification from the Firebase. It is not functional. It is not functioning properly because when we use Firebase in free tier, we don't have. They don't give us a full control, and there is a limit to send the notification or use the other function from the Firebase. And this is the acquired functional requirement. From the authentication, there is registration, login, logout, password reset. And consumer module, there is GPS discovery, checkout, login, profile, and impact dashboard, and etc. Okay, for the conclusion, SaveBite will always connecting the surplus and creating the new value, so the waste will be safe. And SaveBite will always support the SDG number 12, responsible consumption and production. Okay, that's all for our presentation. Thank you for your attention, and don't forget, you can always save or buy the surplus food before it go to the waste. Thank you. Bye.